Hello students, welcome to my channel CM Hub, where you, me and chemistry connect with each other. This platform is a gateway for mastering chemistry. We have done some questions earlier which appeared in the NEET examination. I found one interesting question in IIT 2015 paper 2, which requires a combination of two different concepts coming from two different chapters. One is nuclear chemistry and the other one is states of matter. But before we enter into the concepts behind this question, let us understand the question. The question is given as a closed vessel with rigid walls contain 1 mole of uranium 92-238 and 1 mole of air at 298 Kelvin. Considering complete decay of uranium 92-238 to lead 82-206, the ratio of the final pressure to the initial pressure of the system at 298 Kelvin is. So he is asking us the ratio of final pressure to the ratio of initial pressure. Before again going into the concept, let us understand what is given in the question. You are given 1 mole of uranium 92-238 plus 1 mole of air. Now, uranium is not a gaseous component, it's a radioactive element, it decays. So whatever the initial pressure that is exerted is because of the air that is present. And how many moles of air are present? 1 mole of air is present. So initial pressure corresponds to the 1 mole of air that has been taken along with 1 mole of uranium 92-238. Now what is the second part of the question? Uranium 92-238 converts into lead 82-206. So this is a radioactive decay that is taking place. Uranium 92-238 is changing to lead 82-206. What is it that we need to get from this? Now this is a nuclear disintegration. This is a radio decay which is accompanied with the alpha particles, beta particles and sometimes the gamma particles. If we know the number of alpha particles or the number of moles of the alpha particles that have got emitted at the same temperature, you can know the final number of moles that are present. Once you know the final number of moles, it becomes easy for us to go for the calculation. The first thing that you need to know is the formula to find the final pressure to initial pressure. This is where we enter into the concepts of the states of matter. There is an ideal gas equation. PV is equal to nRT. Now temperature is constant because it is the same 298 Kelvin with which we started the reaction, and it is at the same 298 Kelvin where you are asked to find the ratio of final pressure to initial pressure. So temperature is constant. R is a gas constant, so this is also constant. Since the reaction is taking place in a closed vessel, V is also constant. That means we get the ratio between P and N, where P stands for the pressure, N stands for the number of moles. I write the equation as P1V is equal to N1 RT. V is constant, R is constant, T is constant. P2V is equal to N2 RT. This is equation 1, this is equation 2. Now divide equation 1 by 2, you get P1 by P2 is equal to N1 by N2. That means if you know the initial number of moles and the final number of moles after the completion of the decay, you can find the ratio of initial pressure and the final pressure. P1 is equal to initial pressure and P2 is equal to final pressure. Now whether it is initial to final or final to initial, will come back again. What is it given? He is asking us to find the ratio of final pressure to initial pressure. That means we are asked to find out P2 by P1. This is the formula that we need to apply. So what are those parameters that we need to get? We need to know N1 and N2, where N1 corresponds to initial number of moles and N2 corresponds to final number of moles. Now what will be the initial number of moles? Initial number of moles N1, which we can also call it as Ni, is equal to 1 mole. Why are we using 1 mole? Because uranium, being a radioactive element, not a gaseous compound, does not exert pressure. It is the air, 1 mole of air that is present initially, which exerts the pressure. So now I know initial number of moles correspond to 1 mole of air. So what is it that I need to find out? I need to find out N2. Now how to find out N2? Let us look at the equation. Uranium 92-238 converts into lead 82-206. This nuclear disintegration is accompanied by the emission of alpha particles, beta particles and gamma particles. The change in the atomic number, the change in the mass number that you observe is because of this emission of alpha and beta particles. Some of you learn nuclear chemistry in physics, some of you neglect that particular chapter. But to answer this question, you need to have a clarity on the calculation of the number of alpha particles and beta particles. But how to calculate the number of alpha and beta particles? You need to know the concept behind it. Whenever a radioactive element, now what is a radioactive element? A radioactive element is that which emits, or which being unstable, or whose nuclide being unstable emits the alpha, beta and gamma radiations till it converts into a stable nuclide. Here lead is a stable nuclide. Sometimes you can stop the process midway, forming another radioactive element. But in this particular question, the end product is a stable nuclide. So now the change in mass number that you observe, 238 to 206, is because of the emission of alpha particle. Now what is alpha particle? Alpha particle is nothing but a helium nuclide. Whenever an alpha particle is emitted, the atomic number decreases by 2 units and mass number decreases by 4 units. How many units of mass number? 4 units of mass number. And how many units of atomic number? 2 units. Now whenever a beta particle is emitted out, the atomic number increases by 1 unit. Alpha particle decreases the atomic number and mass number, but beta particle causes an increase in atomic number without causing any change to the mass number. So the total mass number changes because of only alpha. Atomic number changes because of alpha as well as beta. Alpha causes a decrease in atomic number, beta causes an increase in atomic number. So now how to find out the number of alpha particles and beta particles emitted? Number of alpha particles emitted is equal to delta A by 4. What is delta A? Difference in the mass number, 238 minus 206. Why am I dividing it by 4? Because every time the alpha particle gets emitted, the mass number decreases by 4 units. This is 32 upon 4, that is equal to 8. That means 8 alpha particles have got emitted. How many beta particles get emitted? Number of beta particles is equal to 2 into number of alpha minus delta Z. So 2 into number of alpha are 8 minus what is delta Z? Difference in atomic number, 92 minus 82, that is equal to 10. 16 minus 10, that is equal to 6 beta particles. So 8 alpha and 6 beta particles. Now let us write the equation. Uranium 92-238 converts into lead 82-206 with the emission of 8 alpha particles plus 6 beta particles. Now alpha particle is a gaseous component. Beta particle is just nothing but the electronic emission. So here I will not consider any change in pressure because of the presence of beta particle. The change in pressure will be because of the alpha particles. So how many such moles of alpha particles are formed? 8 moles are formed. Now initially there was 1 mole of air. Air is not undergoing any change. So this 1 mole of air will remain as it is even after the conversion of uranium to lead. So what will be the final number of moles? N2, that is equal to NF, is equal to 1 mole of air which does not undergo any change plus 8 moles of alpha particles which are formed, that is equal to 9 moles. So now I know Ni, that is N1, is equal to Ni, which is equal to 1 mole of air. Now I know N2, which is nothing but N final, that is equal to 9 moles. So now I have to just substitute what is that P final by P initial, which is equal to P2 by P1, which is equal to N2 by N1, which is equal to N final by N initial, is equal to 9 by 1. So the answer is 9. Because it's an integer type question, you can simply put the answer as 9. If the answer is asked in terms of decimals, you may be asked to put it as 9.00. If it is asked to put for 2 decimals, if he is asking us to just round it off to the integer value, you can just take it as 9. So the entire concept that this particular question involves is around 2 different chapters. One is nuclear chemistry and the other one is with respect to states of matter. From nuclear chemistry, we understood what a nuclear disintegration leads to. It leads to an emission of alpha particles and beta particles. And the states of matter gives us the relationship between the pressures by using the equation PV is equal to nRT. Since temperature is constant, R is constant, closed vessel volume is constant, we get the relationship as P1 by P2 is equal to N1 by N2. But here he is asking us to find the ratio of final pressure to initial pressure. So we go for it as P final by E initial is equal to final number of moles by initial number of moles. Final number of moles are 9. Initial number of moles are 1. So the answer is 9 upon 1, which is equal to 9. Students, I hope you understood the concept that is underlined behind this particular question. Never get confused, never get panicked whenever you find a question which involves 2 different concepts. You need to just focus on the core idea, that is reading the question, finding out what is given, what is asked, and getting the relationship between given and asked. The only thing that you need to be perfect is the concept that has to be learned for solving such problems. See you again in another video with another question and another concept behind it. Till then, take care. Bye-bye.